Okay, so a few months ago, we were listening to a talk about DNS Flag Day coming up, and someone was talking about the experiences of running the EDNS Flag Day code over a couple of TLDs. So someone said, that'd be interesting for us at ICANN to try to do this with all of the TLDs that we have. And so this is a talk about the attempt to do this. Now, of course, I won't have the same nice graphics that they had in that talk then. For one thing, we're after the Flag Day, so it wouldn't really matter as much. But it was an interesting experience to talk about that. So to give you an idea what this would entail was that if I actually ran every single test that was going to happen here, I'd have 11 billion digs executed. I didn't do that. I mimicked doing 11 billion digs for this. But that's the size of what we have. We have a lot of information. Now, the code that I use, I know that as time went by, the EDNS test code that ISC developed, it changed over time. And when I met with the developer, Mark Andrews, back in October of last year, he gave me a file, a zip file of his stuff. I don't know what version it is. I just have his stuff. And as I worked on it, he kept saying, we should go to the GitHub and get my stuff that's now in C. And at that point, it was too late for me to with all the work getting his stuff to work, I just committed too much. So I'm using a bunch of shell scripts that he had written to do all these digs out there, which is underneath of everybody else's work out there. I know he said that he has more efficient C code. I didn't use that, so this is not really a judgment of this code. Why did we go ahead and do this? ICANN has a contractual relationship with about 80% of the TLDs. That means of the 1,500 or so TLDs out there, 1,200 of them, I have access to their zone files as a result of that. That doesn't mean I have 80% of all of the internet usage of the DNS. It's just 80% of the TLDs because, of course, you know, some CC TLDs, which I don't have any of, are very big, right? And a lot of gTLDs. I could, but I'm trying to, just to make it a little easier to pipeline the stuff. But also, on the other hand, a lot of gTLDs are very small. So the distribution doesn't say, I don't want to promise I have everything out there, but I have a lot of TLDs out there. Basically, we thought it'd be good to run over these 1,200 TLDs out there. The other thing, though, is that I knew that at the start of a couple of things I knew would not play well. One is I wouldn't have a graph reach TLD. I don't want to do that. I'm not racing TLD versus TLD. It's not fair for us to do that. We don't have that as a thing that we grade TLDs on in any way. Also, all of the alerting that Mark Andrews was doing, we don't have access to that. That's a whole other department of who has the contact out there. But it's interesting for us as a protocol now to look at the health of the system. So we got some insight into the EDNS0 situation, not a whole lot because, frankly, by the time we got down to that part of the data, we had a lot of work and didn't do a lot of analysis. But what's going on now is I've been building a platform for eating zone files, parsing them and pulling things out there and finding things. In fact, I've moved on to other projects already since I did these slides last week, and I'm thinking of the new stuff already. One of the lessons from the KSK rollover project was that management of the internet is pretty weak. It's a hard to manage network. So we're looking, one of our interests is to make sure that, or to see what we can do to manage through measurement what's happening out there, to assess whether this is being done, that's not being done, how well are operators linking things up there, like are glue records a good idea, are the glue records good and all, but that's further research than this. So to start quantifying things, the workload we had, 1,228 zone files, 193 million delegations out of that. It's a lot. 450 million NS records alone through all of this. Glue records, 3 million, mostly v4. And I will not go through all the numbers, of course. It's Sunday afternoon and we're at work. Graphs, I don't have any. I'm too lazy. I'm not like Roy. I'm the opposite of Roy. I don't like graphs. I should, but I don't. Now, the problem here is I'd have thousands of graphs, one for each TLD. You're not going to go through that. On the other hand, I think for most of this, any kind of graph that's interesting is a long tail distribution. Just for the most part, I'll tell you when it's not. And the other ground rules, I don't like to name names. I do have one really large gTLD we all know about. I'm not going to talk about it, but I have one really big one. Everything else is roughly less than that. In fact, the one big one I have It takes half the processing time just to parse all of them together. In fact, I did a race one time where I parsed it in one process, parsed all the others, and they tied at the end. 1,227 to 1, same process. Two-thirds of that 11 billion, two-thirds of all of my results would be in that one big TLD, and so on and so forth. So things are kind of skewed. No ccTLD data in this, just to make it, it's easy. I could get the stuff, but I don't want to mix apples and oranges in some sense. And the only ARPA is the only thing in reverse map that pops up here, because we happen to have that. And one thing, when I get to the IP addresses, I change them too, because I know in Europe, IP addresses are like illegal to mention, I think. So anyway. So name server names, 3.2 million name server names. Almost none of them have IDN. Operators now still only work in ASCII. The infrastructure is still pretty much an ASCII thing. Over 99% of all name servers are just ASCII name servers. That means the tools that get into IDN sometimes may be a bit premature for the operators out there. I know there was a flap about one tool suddenly recognizing the native labels, and that screwed up scripts, and I was bitten by that too. Most of the name servers that I deal with are in gTLDs, so it's not too surprising. But 85% of all the gTLDs name servers were actually in a gTLD, the name itself. And again, it's pretty much still all ASCII and pretty much still gTLDs. Glue records, I have 3.2 million glue records. Of that, 2.7 million were unique addresses. Almost all V4, not too surprising. What I found surprising, though, at the bottom of this, I have name servers that only have V4 is still a huge number compared to dual stack. I thought dual stack would be more mature. That's the first number here that surprised me, was that I thought dual stack was just a given, and not at all, not in glue records. There are 5,000 brave souls in V6 only.
Idiots. I mean idiots.
No, I will say the first that they were very smart people in alternate universes. Glue addresses per name server, mildly interesting. There were 750,000 name servers that had no glue. Now, I should point out, after I did the slide, I realized it's actually not really a bad number, because 450,000 of them were in ccTLDs, which means I don't have that glue. It's very important. Now, that's why it's good to have the split. So most of the ones that have no glue in there were glue I shouldn't have had anyway. So that's excusable, very excusable. Others just because they're name servers that are somewhere else. And then I'm discovering now there's a lot of bad glue, but that's beside the point. Most servers have one glue. This is not a long tail situation. It's kind of funny. It goes 2 million for one, then down to 50,000, down to 3,000, then back to 69,000 for four, and so on. And by the way, 0 to 13 is the entire range of values for this graph. There's nothing below that. This is all of it. Because, you know, we can only have 13 NS records, because by law it's, never mind. A lot of registries actually assume that when they wrote their original code, so it stayed that way. Now, in this study, later on I'll talk about a bit more about addresses. It's kind of murky. I call this muddy data, because the glue records, studying glue records itself as glue records has a whole lot of things I can do with it. I'm doing that right now at my next level. But this tool would actually then, if you gave it zero glue, it'd go out and get authoritative data and then mix it all together. So some of my stuff about addresses later on a little muddy out there, but interesting to do. Eventually, I would like to separate that and do what's authoritative versions of the data versus the glue, and see how we've kept that up to date. Zones per name server, almost 2 million name servers out there of the 3.2 million only do one zone. Now, that could be vanity naming, could be all different names for the same process, but that's the way it lines up with the NS records. I go down there, you see this is a long tail, and then Maxwell, the next slide was kind of interesting. There is a name server out there that has over 4 million zones on it. Okay, it's, what I find interesting is that I mocked up the names on purpose, of course, because I don't like naming names, but the 2 and the 1 in the first 2 lines is on purpose. Some operators, NS2 has more zones than NS1 at the 4 million mark. I would think if I had that many zones out there, I would have NS1 be bigger, because all the other ones are. Or I would have it balanced, or I'd have it automated in some way, but it's your name servers?
No, it's not. No, I sometimes see that a domain will either have NS1 and NS2,
right,
or some name server owned by the domain owner
Right.
plus NS2. But
Yeah.
for that, the difference is too small.
Right. Yeah, it's just interesting. You're saying that in some cases you see an owner in NS2 for the recording, basically.
Yeah.
But the other ones, the other big ones, NS name server 1 and 2, and these are the top 6 name servers out there, and it falls down quickly. There were a couple more at 2 million, but everything else fell right down. But I just thought it was humorous that the top one there had a few more zones on 2 than 1, and that's weird. Okay, so multi-tenant, this actually came from the conversation, this idea that how many zones are actually on a process? I mean, you have a name server process, right? You have name server addresses, you have name server names, and so on. And I've worked in places where I know how we mix and match these things. It'd be interesting to be able to trace that out. This study can kind of hint at that, but I haven't gotten there because in some cases we have vanity IP addresses, vanity name servers out there. That's gives you the high one-to-one situation. There are ways to figure this out over time, and maybe you're just going to find out to help look at what's the structure of the DNS hosting out there. How many major operators out there? How many minor operators out there? So we can start balancing some of our assumptions about the CDNS, CDS records. Who you're talking to out there? I think it's interesting to know who's doing that, and the consolidation stuff, and the whole Dyn attack a couple years ago. That anyway. So it'll be interesting to know who has what where. TLDs per name server. This is not as interesting, but I put it up here anyway. Most name servers only have one TLD represented, meaning the zone that they serve is in one TLD. There were 2 name servers that had zones and 539 TLDs out there. Hosters can do what they want. So now, compressing the tests. Now, many people have done this, recognize the idea that the way this thing worked, for every zone on every name server's IP address, it would run the set of digs. And it's probably not necessarily do that, so we'll just pick one zone and just, okay, so I did that. I picked out one. I thought there'd be a 144 to 1 compression value in doing that, giving that about 144 zones per name server if I did a straight out average, which meant basically the middle here, expected tests. I expected to have 2.7 million tests plus some unknown number for the glueless because they wouldn't be discovered until I ran the tool. Now and the rest of it, why I bothered to put this up here was that I had to estimate how many VMs I needed to run all this stuff, and that's why it was important to me. So when I launched it, I came back, I had 3.5 million total tests out there. It breaks down a certain way. Now, when I expanded back by now saying for this name server, all the zones, I multiplied it, that was almost 1 billion things tested, 999 million, and so on. That was a 283 to 1 expansion. I had forgot about addresses multiplying in there. I was able to actually do all the parsing and take all the data in 24 hours, which I find important because it's fresh. Analysis took another day or 2 of the data, but at least the data was all pretty fresh from the zone file. For the glueless, I found basically most of them only had 1. And again, that 1.465 is very close to the number of name servers that were in ccTLDs, so that's not too surprising that I got 1 out there. One of the servers that had no glue in my files had 58 address records. That's the top end. There's one at 33, and the long tail applies here. And it's interesting to see with those. Now, interesting, looking at just the addresses. Oh, sorry, I got a question.
On the last one.
Yeah.
How many was errors?
How many were errors? Well, the first one, 210,000, were either NX domain or no error, no data.
Yes. How many was them? Oh, okay, so they are errors.
Right. So these represent name servers of zones that are obviously, well, these are name servers that will not answer. Right. Probably the zone is probably broken. I haven't gotten too far into that, but I'm sure there are some zones out there whose all name servers just don't work.
It's a new error, new error. I mean.
Oh, no error. Oh, sorry. No error is when you ask a question in DNS, and it turns out the name you want has no information anywhere. That's called an NX domain, right?
Okay, yeah.
But if the name exists, the name actually has information about it, but doesn't have address records. We call it no error, no data. Sorry, that's a protocol jargon in there. So that meant that the name existed, but it wasn't there to give you an address. So
if you got a C name back there, it would be one of those.
A C name, it could be a MX record, TXT record, it could be a delegation, it could be anything, but it didn't have an address record. So I didn't dive into why. So this is what I call muddy data. This is glue record and authoritative data. So let me just skip across here to V4. In V4, there were 1.1 million addresses, 692,000, about half of them were one name server had one IP address. The other ones, there was some sharing going on. And what I have here is some of the A1B1 stands for /16, which had 332,993 name servers named in that /16. It doesn't say a whole lot at the top. But if you look into the /24, A1B1C1, there was almost all of them were there. And if you go down further into /24, I'm sorry, I think the slashes are off. All of them are pretty much in one /24, which means now in the 255 range, all those name servers are all fitting into that. And I'll go into the next slide because it's really funny to look at that. And also to give you a size of scale, the next 16 out there, A2B2, again, I obfuscated the IP numbers, had only 46,000 name servers out there, and so on. The structure, this is less interesting. You don't see the real numbers. Down in the top 6, there was one that showed more of an even distribution of there were 21,000 name servers in this /16, and there were about 5,000 each of the /24s below that. Something looked more natural. For that one really large /24, I actually have these counts for each of the numbers that appear there. There are 16 addresses in that /20, that 255, that /24. They have between 21,000 and 20,500 name servers. So obviously, someone has done this on purpose, where they put all these names on here. And it's just really funny. These two are 2 blocks of 8 addresses. They do belong to one provider because I know what the names were in there. But the other thing that's funny about, usually when I do things like that, I usually like to have routable blocks. These don't line up with CIDR blocks. So I don't know what the deal is here. Someone has these 16 addresses and put in 330,000 name server names in that spot, and they're running. So, and they have to be inside of a hosting provider because they can't route that. You can't route a /29, which is what that would be. But it's not even a /29 because routing would have been like 4 routes or whatever. Sorry. Anyway, I just found this really quirky. And then to give you the scale, these are the next ones. B, C, and D were the next blocks that were that big. So again, this all goes back to finding out how many people are sharing an IP address for name servers. Now V6, because V6 has so few addresses available, I looked to see who was sharing there, and there is some sharing there. In one /48, 48 bits out of the 128 bits, there are 2,000 names. So that's not a big deal. There's a lot of addresses there. But the next two, add 2 and add 3, have all of those addresses on one address. /128 is the full address. So there were 1,751 name server names pointing to address 3 and address, or those two address 3 in those 2 blocks. So someone out there put that many names to one V6 address. Apparently they're running out of space. I don't know. And then to give you an idea that there are other culprits out there, if you look at single IPv6 addresses, 867 down to 416, there are that many name servers per that address, which I don't show because it's illegal to show address, I guess. But some people are actually sharing an address in V6. We must break this habit, folks. So, almost at the end of my slides, and I haven't gotten EDNS0 yet. But it's interesting how much work, there's much work that can be done for this. Well, okay, I'm going to just go into this, and I have these results. These were the results that came out of the testing. Now, if you see in here, I have 997 million total at the bottom here, a total test that would have been run. These are the virtual tests being done. 91% to the DNS was okay, which I find really high, which is good, considering all the other issues I found. For EDNS0, 76% said they were okay, because these are name servers, not zones, and concern are over zones and operators and all that. For the DO bit, which I expect to be high too, 77% said okay there. And Shane, you looked.
Is that higher than the last one?
Yeah.
How's that possible? Noise. Wait. It happens. Oh.
Yeah. Good course. I mean, a good reason to squint your face up.
Yeah. The DO bit requires EDNS0.
Right. So let me repeat this. You're saying that the DO bit here, which has higher good, then basic EDNS is kind of funny because EDO requires EDNS0. That's just for the recording. Yeah, yeah. So yeah, that happened. EDNS TCP, 58%. There were like 11 tests. I didn't put them all in here. I picked the ones that seemed the most obvious to just talk about. This one seemed to be in trouble. Of course, if it really was in trouble, I have 10 whole minutes to go. Let me tell you a story about. Oh, okay. So I figure on one hand, it's February 3rd now, 2 days past Flag Day, and if Rome was burning, we'd have known about it by now. But I haven't heard anything about that. In fact, I didn't see any talks here about EDNS0 Flag Day at all. So I'm assuming that it kind of went well. So I'm not, again, I didn't really spend as much time on this because ran out of time, and also it was so much fun setting up the experiments. And the address not found failures, and this actually goes to a question earlier. I have no address records and no addresses found because I forgot to put the NX domain in here. No address records was the NX domains. These are the names. There's 76%, 75% or so of all the ones that had no address didn't exist in the DNS. But a quarter of that were names that had something other than an address record. So that's how that melted down. So lessons learned. One thing I say for this tool is that I tried to get a clear yes or no out of the tool, and I was given a long-winded response about how you had to judge all this stuff. And I get the reason. It would be nicer if this tool had given us thumb up or thumb down for the server's address for EDNS0 compliance, but that was kind of out. That wasn't going to happen. To me, the important thing was that it gave me a framework now for studying other parts of the registration system. I'm trying to get so that I want the data to be done in a day, so it's fresh data. It may take longer to analyze this stuff. But there are a lot of things in there that we can go in and look at. One thing that I've always been concerned about, the reason why I have so many numbers and counts here, is that I'm always into, have I actually captured all the results? And I'm trying to make sure I don't leave anything on the table. Timeouts always bug me. I want to make sure that I know how to handle these things. So if you're writing tools out there, be really good about making sure that every response that comes back is recognized by the requester, and that we can count to make sure that we have everything accounted for. Because I found in here that there were some places that I realized I missed something, and it opened up a door like, oh, there was a bug. I forgot about a certain set of servers over for a while. So the goal of this is to improve the ability to manage the DNS system. Managing meaning not to regulate or push it around, but to know where to put more attention for improving parts of it. What parts of this will make DNSSEC go faster? What parts will make everything just click much easier? And then to wrap up, how did I get to 11 billion digs? I had 997,000 total DNS tests. That was from one of that. So each one of those represented 11 digs. There was in the test. There were 11 things. I think it was 11 it went for. And the glue list had 726,000 more digs to get their authoritative address. You add that up, and I use DC because that's all I've ever learned how to use for a calculator, and I get to about 11 billion would have been digs out of all of this. So it only appeared in DC. It didn't appear in any. There was not 11 billion pieces of traffic out on the internet because of this. So that's what I have. Hopefully, it's been entertaining. Nothing else. Any questions? I know you all want to go home. It's Sunday afternoon.
I have just one comment regarding DNS Flag Day. We did some research on that, and we also reached out to the providers, and we got it for the half. So half of the providers fixed it within that range. So there is some improvement if you reach out to them and say, go and fix your service.
Okay, so
many gTLDs have seen this in January.
yeah, so a comment was that a lot of improvements were done in January, and to reach out to improve it, to say that to avoid world disaster. Yeah, okay, that's good.
I have similar comment. You see that, for example, we went basically to 0 error rate during January.
Yeah.
And it was constantly improving during January. Even there was a difference in the last week, which was like 0, or measurement error was the error rate in the end.
Okay, so the comment about CZ's experience, they brought down to 0 error rate. Can you do that for the KSK, by the way? We're at 2%. That's good. It's good. Yeah.
It would be interesting to see if studies say what actually was fault in people's implementation was. What we saw mostly was action of the DNS software, but where the file was in front of it, somewhere on the layer. Just 8
Yeah, one of the comments, the comment here is that the DNS firewalls are causing a lot of this. And I understand that's actually why this tool was a little hard to get a yes/no answer. I have a lot of experience with doing this kind of testing, and to me, a timeout always meant I didn't know what was going on out there. And so I wouldn't qualify that as an error, but as an unknown. But in this case here, it was different because sometimes you could get through there, and when you get a timeout, that helped you pinpoint that the error was, there's something else going on. So knowing that would change how I would analyze all the results, but didn't get into the ability to quite understand all of the intricacies of that. I know Mark Andrews has spent a lot of time on this and helped contacting people with that. Certainly, he flooded me with too much information, basically. So I'm sure others are familiar with that. So any other questions? Okay. All right.
Well, did you attempt to do some outreach to these TLD operators to see if they can improve the situation?
We hadn't for a couple of reasons. Attempting outreach to TLD operators. For one thing, I think Mark had advertised that he already had. And I think by the time I ran this stuff, Mark was saying it was all pretty much taken care of. So I didn't even really think about doing that. Secondly, we have a certain set of gTLDs we can talk to. The CCTLDs, there's an interesting dynamic there where some CCTLDs want to operate on their own merits. Some appreciate information, and so we're not as forthcoming with some of the we may probably should be. And as far as contacting anyone else involved here, we don't have a direct relation. We can't just go out to the zone owners because that goes through the multi-layers of who's in charge of out there. Had this test been done a year before Flag Day, and we found that there were things that needed to be contacted, I'm sure we would have worked out how to do this. But given the timing that this was, the data, all this data came from January 18th, which is last minute to even get this thing launched and running. I didn't even try. I didn't even attempt the outreach part of this, which is actually what the goal was. So I relied on other efforts out there. So. Yep.
One comment regarding how to do the scans. There is a tool out from the colleagues of this ethnic that's quite fast.
Yeah.
To perform all the scans, and you have the summary and.
It's on slide 4, I'm going to say.
Yeah. Yeah.
The problem is that it would consume too much memory for such a result. It wasn't optimized for COM.
Yeah. Half of the comment is that CZ has a tool for doing, partly because I'm too lazy to actually do research. I didn't look at it that much, but I also assumed that it would have blown it over anyway. So I didn't feel that bad. I didn't bother, and because I was looking at the code that Mark had given me. And I did use some of his reporting, and I decided just, having an HTML page with red and green wasn't going to scale to 450 million NS record. That's why it would have been brilliant to have used that, but also because I didn't want to split my data up by TLD because I didn't want to have any kind of a horse race of TLDs. That's one thing that's important. I'm trying to look at this like broads of all of it out there. So. One thing that's important is you have to have goals in mind for when you do this research. Like, what do I want to measure, and what do I want to know, and what do I want to present? In some cases, you don't want to do horse races, but you want to do a qualitative protocol thing. So, yeah, there are different ways to use the same tool. That it comes down to.
Any final question? No? Thank you, Edward.